Now we'll be going through dynamics tutorial 3. So from tutorial 3 onwards there will be curvilinear motion, or more accurately this whole tutorial is based on curvilinear motion examples. So for question 2, we are given this question. So at a given instant, the jet plane has a speed of 120 meter per second and an acceleration of 21 meter per second square, acting in the direction shown. Determine the rate of increase in the plane speed and the radius curvature, which is rho of the path. Okay, so we are just trying to find rho, and this is relatively simple because we can relate velocity with rho through the centripetal acceleration. So we will write the equation for centripetal acceleration, which is v squared over rho. We know v is 120 square over rho. We don't know what's rho, but we know what's centripetal acceleration, which is just 21 sine 60, which is over here. So very easily you can find what is rho. Okay, then with that, you want to find tangential acceleration because I want you to find the rate of increase in the plane speed. So basically we're trying to find the acceleration vector along this v vector, this velocity vector. Hence I just cosine 60, 21 cosine 60, and I can find the answer. So that's question 2. Well, for question 3, we have a motorist traveling on a curved portion on a highway of the radius 350 meter at a speed of 72 km per hour. The brakes are suddenly applied, causing the speed to decrease at a constant rate of 1.25 meter per second square. Determine the magnitude of the total acceleration of the automobile A immediately after the brakes have been applied, and B 4 seconds later. We can first convert 72 km per hour into 20 meter per second because that's the working units for our calculation. Then we can do the centripetal acceleration, which is still v squared over rho. We know what is v because we converted already, so v squared over, we also know what is the radius rho, 350, and we can find the centripetal acceleration over here. So it's along here. And we know the tangential acceleration is actually 1.25, but it's actually decreasing, so it's decreased at a constant rate of 1.25. Just take note that it's supposed to be negative. But the reason why I left it as like this, it may not be as accurate because when you square root, the negative is going to be gone either ways. So I just leave it as it is, and I can find the acceleration. Okay, so once I find the acceleration already, right, then the next thing that I want to do is I want to find out what's the acceleration after the brakes have applied 4 seconds later. And we know that it's decreasing at a constant rate, so I can use the kinematics equation. So I use Vf equals to V initial plus acceleration times time. Vf I do not know, I know what's the V initial. Acceleration I know is decreasing at negative 1.25 multiplied by the time. And I know after 4 seconds later, the speed of the motorist would be 15 meter per second. Again, I use the centripetal acceleration formula, and I can find the normal acceleration, which is the centripetal acceleration, to be 9 over 14 meter per second square. And I can find the magnitude, and that will be 1.4056 meter per second square. So that's the answer.